All right, here we are trying to condense some log expressions. So here we're given a big string of logs. First thing we want to do if we're going to condense is make sure that all of the logs have the same base. That's the only way we can use the properties. So here it's log base B, log base B, log base B. All right, now what I'm going to do is I'm going to start with any of the numbers in the front and I'm going to move them up as powers. That's usually the first step. So here I'm going to move the 5 up here. Here I'm just going to leave it. It's like a -1. I'm just going to leave it. Here I'm going to put a 1/4 up here. So I have that this is equal to log base B of x to the 5th minus log base B of y plus log base B of z to the 1/4. Now what we're going to do is we're going to try and put these two together. And we're going to move from left to right, right? So addition and subtraction, you always move from left to right. So I'm going to put these two together. Remember, subtraction becomes division. So this is going to become a single log, log base B. The numerator is x to the 5th. The denominator is y. Okay, all of that, and then plus log base B of z to the 1/4. Okay, now we have addition of two logs. So when you have addition, they can come together to one log, log base B. But now you multiply this times this. And remember, that's x to the 5th over y times z to the 1/4 over 1. And those go together, so the z is going to be on the top. So we're going to have x to the 5th, z to the 1/4, which I'm going to write as the 4th root of z, all over y, which was still down there. So now we've condensed it down into a single log expression. Okay, now, next thing, our next problem is this one. This one's a little bit tricky, so let's work through it. I'm going to erase all this so our minds get a little clearer. And now we want to move those powers up to the top, right? But notice that we have something in brackets and then a number sitting in front. So before I move the powers up, I'm going to get rid of the brackets by distributing a 3 here and here. So that'll give us a 6 natural log of x minus a 3/4 natural log of z. And then this was not in the bracket, so I just leave it out here. 1/2 natural log of x plus 1. Okay, now what I'll do, I'll move from left to right because I have addition and subtraction. I'm sorry, no, I want to move those powers up now, I forgot. 6 comes up, 3/4 comes up, 1/2 comes up. So what I'm going to have is natural log x to the 6th minus natural log of z to the 3/4, then plus natural log of x plus 1 to the 1/2. So all those powers came up. All right, now what I'd like to do is put these two together. Okay, remember, division becomes, subtraction becomes division. 2 logs become 1. So I have natural log. I'm going to have the x to the 6th on top. I'm going to have z to the 3/4 on bottom. Then I still have plus natural log of x plus 1 to the 1/2. Now don't get confused here. We do not have a property that allows us to do anything when we have two things being added inside of a log, right? Only when they're being multiplied. So we can't do anything with this. We can't break this up. But what we can do is say that this log is being added to this log. These two logs will condense down to a single log. And it'll be this thing times this thing. And remember, this is like a fraction over 1. So what we're going to get is x to the 6th, x plus 1 to the 1/2, that's this part, all over our denominator, which is z to the 3/4. Okay, that's the final answer. You could, if you want, clean this up a little bit by putting natural log. You could put x to the 6th. You could rewrite this as the square root of x plus 1. And on the bottom, if you wanted to use rational exponents converted over to radical, you would have that this is the 4th root of of z cubed. All right, and that would be your condensing of that original expression.